basically there are exceptions that come because you're trying to divide by 0, the exceptions that come because of an incompatibility with the type of the object you're trying to work with, different kinds of exceptions. But the main thing is every time Python raises an exception is because you're trying to validate a rule, all right? And when you validate that rule, Python crashes your program. That's what exceptions do. Exceptions crash the program. So yeah, what do we do about them? How do we handle exceptions? Now, there are different ways you can handle exceptions. We saw one of them that was some days back, and what we saw was how to use decorators to handle exceptions, all right? And we did that, but there are some other ways we could handle exceptions, like using the try, except, else finally block of code. So let's look at them, just build something, all right? Around this, let's just build something around this lines of code, and then let's move from here. So let's say I want to have a function. Remember I told you in Python, whenever you want to do something, it is always good to create a function for it. So I want to create a class, I want to create an object, I want to do whatever. It's usually best you do a function definition, because that way it creates a Python, let me use the method, if you like, that you can replicate at every point in time by just calling it, instead of having to repeat that line of code. So for example, I want to write a function that divides two numbers. So let me pick, let me call that function divisor, and it takes two variables or two parameters, X and Y. All right. Now, when I do this, when I call this function called divisor, the return value I want to get would be X divided by Y. Very easy function. All right. So let's just run this function, and Python tells us, hey, okay, so you guys don't have any problems. Okay, so Python is still trying to allocate memory to my collab. Let's see, collab is trying to allocate. That shouldn't be a problem. Okay, yeah, good, we're connected. So Python tells me, hey, there's no problem here. Now, let me call this function called divisor on two stuff. Let me use two numbers, 5 and 2. When I run this, 5 divided by 2, obviously it's going to give me 2.5, all right? So that's what we have here. Now, what if I do 5 divided by 0? It's going to give me an exception. See? So the name of this exception is called zero division error. And what it does is it's telling me, hey, you cannot divide by 0. So how do I deal with this? I told you we could use decorators, which we saw last 2 weeks or 3 weeks ago, but there are some other ways we could deal with this. So we could just create a try except block that handles this. So what we can do is when we're writing this function, we'll say, Python, the first thing you should do is to try. So what are you going to try? Try X divided by Y. All right. And if you try that, if it raises an exception, if there's an exception, what should you do? All right. So you can say if there's an exception, print, please, let me just put this in quote. So please do not divide by 0. So I'm going to just remove this. Okay, so I'm going to remove, let me remove this, and then let me see what happens when I run this function. So let me call this divisor here. Now, so you see what happens when I call the divisor? because I have told Python, when I run this divisor, try x divided by y. If there is an exception, which is what this except means, if x divided by y gives you an exception, then print do not divide by 0. All right. So when Python looks at this, it says, okay, this is going to give me an error, and I'm going to return what the exception gives me. But if I put 1 here and I run this, so you just see that it returns, come on. Okay, so let me put a return value here. Try return x, y. Okay. So yeah. So now, cool. So this works. So that's what I just told Python to do. So when you try to return x divided by y, if it gives an error, then return the exception. All right. Sometimes you might decide to expand the code with which you want to handle the error. So you might even want to say, if there's an exception, a particular kind of exception, all right, give me another result or try something else. Okay, so in that case, you could say if there is a, let me use this here. Let me use, okay, before I go into this, let me do the else first, then we'll go into types of exceptions. So here we add another block of code called else. Now, what is this else going to do? Very simple. The else is going to try to evaluate, okay, I've tried this. If it brings an exception, print this. Else, print this. So let's assume that the kind of exception I was expecting, all right, or maybe let me just do this right now. So you could always copy this link. Let me open, let me just copy this and open this link. So what we have here is, a list of all the built-in exceptions that we have in Python. So there are the exceptions that generate warning. There are a lot of them, all right? There are exceptions that come from the way you treat base classes, which we're going to look at when we see object-oriented programming. There are some that come from like some of the, okay, like this is a generator error. Oh, okay, so Emmanuel here, this is a notebook I'm working with. So Control Z, let me just copy it and paste inside here. All right, so that's it. And you can take a copy of the notebook yourself. Thank you so much. Okay, so what we're going to do right now is we are going to look at, okay, so this happens when you use a generator. We're going to look at some of these, and modal not found error, index error, key error, keyboard interrupts, you know. So these are all kinds of exceptions. So, but like for the one we are working on right now, the kind of error is going to give us is a 0. I'm sorry, I'm scrolling. It's a 0 division error. All right. So let me copy this and then tell Python. So let's tell Python that, okay, let me use another kind of exception. So let me use Unicode encode error. So I'm just going to tell Python that, hey, if you run into this kind of an exception, all right, print, please do not, okay, so let me use this here. Print, this is a unicorn. I'm just using unicorn, right? Unicorn problem, all right? So just something just weird. Else, print, please do not divide by 0. So what I'm telling Python to do is try running this code. If you run into an exception, first check if it's this kind of exception. But if it's not this kind of exception, then run this line of code. So I'll run this right now, and I'll run this divisor. So right now, 5 divided by 1 is 5 is cool. Python doesn't have any issues. Now let me make this a 0. So when I make this a 0, okay, so it gives me okay, it's bouncing this Unicode error. So let me change this to 0 division error. Just change this to 0 division error, and it shouldn't be a problem anymore. Okay, so in the event of a 0 division error, what should Python do? Let me remove this else block of code. So I think that this is where the problem lies. It wasn't in, the problem was not, okay, how come you did not catch this? Or Noro or Ashwini, none of you caught this bug. So I'm going to go back to Unicode error. Just going to put this here, and let me run this. So I think I know why it gave me that error. Okay, so print, this is a unicorn problem. Okay, so let me change this back to a 0 division error, and just for okay, so let me just remove this block of code, and let's run this. So let's see what happens here. Okay, so again, this error is just an extra dimension. But what I'm trying to do is I'm trying to just say, okay, what if we find another kind of error? So I could put another block of code here to say else. That's if it's not that kind of 0 division error you run into, you could also print, hey, okay, sorry, else, print, hey, what are you doing? Okay, so so that's, and then there is the last block of code called finally. All right, so what does finally do? Finally is like a line of code that just runs irrespective of the result of all the other things that you have done. So finally prints, I think I will have a coffee after this. All right. So that's just what this line of code would do. So when I run this,
so
yes,
what's
go ahead.
the difference between the finally code and an else if?
Okay, so see this finally disregards everything that has been happening before right now. For now, that's what it does. So what you're telling Python is, when you're done with your exception checking, you've tried, you've accept, you have done the else, whatever you're done with, finally, when you're done with all of them, just print this for me, all right? So that's the difference. Now, you can also use this in the if else block of code, but it could be very messy. So I didn't want to drag you into that mess, but we could do it together if you want. So yeah, John, if you want
No,
that.
I don't need to see it, but basically, like you're saying, you can do the try, else, finally, or if, else, else if. They will basically give you the same response.
Exactly. All
Okay.
right. Yeah. So when I run this, so you see that Python first tells me, please do not divide by 0. And then it tells me, I think I will have a coffee after this. So this is because finally will always run irrespective of whatever all of these lines of code are doing. So that's basically how this thing works. Try, except, else, finally. So these are the usual culprits you would use when you're trying to handle errors inside of a function. So these are the errors, the kind of errors you would meet, and they all, yeah, we'll talk more about them when we start working on classes. And sometimes you might need to raise an exception. And what happens when you raise an exception is very simple. You see what happened when I clicked on this and Python showed me 0 exception error. That was just what raise does. So raise helps inform the user what kind of problem he's causing. So let me create an example. So just something like this on the fly. So let me use names, all right? So let me use the names of 3 people in the class. Or should I do this? No, let me do something else. So let me say, okay. Let me just use, instead of using a function, let me just use a regular keyword. So let me use names, all right? So names equal to, I'm just gonna pick 3 names. I'll pick John, and I'll pick Emmanuel, and I'll pick Tima. All right, so now, if I want to check if a particular name, all right, is in this list of names, all right? So I could decide to say if John, all right, is in names, prints, sorry, yes, so print grades. You are cool, all right? But if John is not in there, so what happens? Else, raise an exception. Now, when I use this raise, I now tell Python what kind of exception I want it to raise. So that's what happens using the raise keyword. You just try to guide the user. All right. So what's the right way to put this again? Okay, so yeah, let me use this. So raise, let me use exception. All right, so raise exception, and let's the exception now. Should I have that exception inside here? What's the right syntax again? I've forgotten. Okay, let me try this. So raise exception. You should check the names. Okay, let me run this code. I hope it works. Okay, yeah. So what if John is not in the name? Let me use James, another name that is not in there. Let me see what happens. Okay, so exactly. So you can see what I was trying to do. I was trying to tell, yeah, so that when a person sees the error, he will know exactly where the problem is and what kind of error, that is being generated. So with this, the person would now know, okay, so this is what I want. This is what I would see, all right, when I call this function or when I do this thing and it doesn't happen. So that guides, it just guides the person to know, okay, so this is what you're doing wrong, all right? So that's basically it. That's when you use raise. You use raise basically when you're building classes to just say, hey, just in case you do something, if it doesn't work, then this is what I want you to know about that problem you're seeing so that it doesn't look like gibberish, all right? So that's what happens in raise. Do we have any questions? Else, we would just proceed to object orientation. Any questions? Any contributions? Any dissatisfaction? Okay, so I just assume none. All right. Now, let me share my whole screen and all right. So I know you've heard of object-oriented programming before, and when I first heard of object-oriented programming, I'm not going to lie, it messed with my head a bit, messed my head up. Object-oriented programming. I first asked myself, what the heck is object-oriented programming, and why should we care? So, this is OOP, all right? Now, what is object-oriented programming? It's basically a programming paradigm. And I'm going to explain what a programming paradigm is. A programming paradigm is just the predominant way you write a program. There are three of them, basically. There is the procedural programming paradigm. And for those of you who were in the world when BASIC was a thing, Visual Basic, QBasic, and a couple of other basics, you would notice that you had to write codes and procedures. So you first have a sub procedure here that will do this and do this and do this. And then you have another sub procedure, and it's just really crazy. All right, so it's still one of the things I hate when I code in Excel. So, but I want to believe that shortly, maybe one of the days when we have time, we're going to look at some other ways to deal with code in Excel without having to use Visual Basic, because it's really annoying. So that's procedural language. Now, there is another kind of programming paradigm called functional programming. If you have ever coded in Haskell or Clojure, all right, most of these languages are functional. So what it means is that everything you want to do has to be embedded inside of a function. So the whole program is just calling one function after the other, and yeah, that's okay. Tima, go ahead.
Yeah, that's right.
Go ahead, Tima.
Wait, then.
Okay, I think that was an error. So I'm just going to go ahead and get Tima muted. All right. So the third programming paradigm is OOP. So let me just explain to you what OOP means in a simple nutshell, and we're going to go straight to writing code. And yeah, now this is how it works. So let's assume, John, I come to your house. So John, I like to eat noodles. I like Chinese noodles. I like Singaporean noodles. Then I like, apart from obviously the noodles we have here in Nigeria where I am presently. So, so let's say I come to your house, John, and I say, hey, John, I want to eat some noodles. Now, usually this is how the whole process is going to flow. So you're going to have to, number one, check. Just give me a second. Okay, so you're going to check for whether you have noodles in the house. And if you don't have any noodles left in the house, you're going to something like walk to the nearest mom and pop shop, all right? And that's the first thing you're going to do. And then buy noodles. Then you're going to come back, and then you're going to boil water, all right? And then you're going to make noodles, okay, boil noodles. This is just simplistic, all right? Some people like their noodles very crazy, so they get to do a lot of processes and then serve noodles. So this is what's going to happen if I come to John's house and say I want to eat noodles, all right? It's just a very simple 5-step process. So let's say I love the noodles John prepared. The noodles were crazy, as in so interesting. And then my younger brother is wedding, so I come to John and say, John, guess what? I love the noodles you prepared for my younger for me that I came. Now, I want you to prepare the same noodles so that we can serve the guests at my younger brother's wedding. So remember, this was just me. And then now we have John serving 5,000 guests. I can bet you my next salary that John is not going to walk to mom and pop shop, buy noodles, boil water, boil noodles, and serve noodles. Remember, the end point is serve noodles to everyone who's present, whether it's just me or the 5,000 guests. It's the same result we want to get, serve noodles, right? So what is John going to do? John is not going to say, hey, let me walk to the nearest mom and pop shop. Hey, the mom and pop shop beside your house cannot obviously have enough noodles to cook for 5,000. And even if they have, which will be a big surprise, your gas cylinder and the cooking utensils you have in the house cannot take care of all of this. So we'll have the conundrum, big problem in our hands. What John is going to do instead of doing this is that John is going to handle this creation of noodles as a project, which means that every function here, every task here, every procedure here is actually going to be assigned to somebody. And then John is going to be the project manager, and he's going to make sure that all of these are assigned as tasks, all right, to people. So let's say the first is to buy the noodles. Obviously, mom and pop shop and this one will buy noodles. But because we are looking at buying noodles for 5,000 people, we are going to have to make this like a procurement stuff. So this person, all right, that is going to handle, let me just swipe this here. The person that is going to handle the first task 1 and 2 is going to be called a procurement manager, all right? So, and what this person is going to do is buy noodles, all right? Ensure noodles move, you know, to the place, let me call it the kitchen, all right? Noodles get to the kitchen, all right? So ensure noodles get to the kitchen. Now, the next task, boil water, boil noodles, will be handled by another person called the cook, all right? Or if you want to call it the kitchen manager, just in case nomenclature is your thing. So, and this person would handle boil water and boil noodles. Okay, so now the third will be serve noodles. Okay, so now we'll have somebody called Shafi, or no, it's not Shafi. Come on. Come on. Come on. What do they call these people? No, Valet are drivers. Somebody help me. I just forgot their names. A chauffeur is a driver. A valet is a what do they call these guys?
What are you looking for? Servers?
Okay, servers. Thank you. Wow, can't believe I forgot this. All right, so so we have these purple hoods, and the task we expect of them would be to serve noodles. So you see that these procedures, which we had earlier, that John did alone, all right? We have discovered right now that because of the sheer size of the event John is trying to cater to, 5,000 guests, John has to take another paradigm to these same steps. And it's called project-oriented paradigm, all right? So, and what is the difference? In this case, this was just John performing a set of procedures, but in this case, there were some people who were assigned these procedures. Now, change this from people. Let's call them objects, because in Python, people are seen as objects. Sad. All right, so that's basically what's this. So now there is a procurement manager object, all right? There is a kitchen manager object, and there is a server object. So now we know that, okay, so we need to hire somebody who is a procurement manager. He should buy noodles and he should ensure noodles get. So these two are the tasks that we want them to do, also called functions, all right? So you can call them functions. These are the functions we expect from these guys. And then this is the function we expect from here. All right, so cool, we're getting close. Now, before we hire somebody as a procurement manager, there needs to be some attributes we need to see. So one of such is that they probably should have experience, all right? As in procurement. Obviously, they should have a name, because we can't just be calling somebody, hey, procurement. So they should have a name, all right? What other attributes do you think we should see for somebody who is a procurement manager? Somebody, anyone? I know they should have years of experience, they should have a name. What else should they have? Okay, same for the cook. A cook should have experience cooking, all right? And then should have a name too. Same for this guy, the servers. They should have some experience. Well, is experience necessary for servers? I don't think so. Okay, so let's just scrap experience. Let's just leave name. So you see this stuff? These are called attributes. All right? These attributes and these attributes. So basically, what is object-oriented programming? Object-oriented programming is a way to break down programming tasks or procedures in such a way that objects handle the various parts of the task you want that program to perform. And you have attributes that those objects should possess, so that when Python or whatever is running the code sees those attributes, it recognizes it as a valid procurement manager object or kitchen manager object or server object, right? So that's basically it. So you would have heard somebody say, when we do object-oriented programming, we are just creating objects, and every object should have two things: attributes, which is what we expect of them to possess, and then functions, which is what we expect of them to perform. So with these two things, anytime you see these two things, you have a valid object. Now, what we have discovered is that it could be very daunting just creating objects, all right? Just creating objects. So rather, for example, it's usually better you create something at the species level or at the class level. Let me explain. So if I want to refer to fishes, all right? Fishes belong to a class called Pisces. Pisces have attributes, all right? Like they sleep with eyes open. Okay, so sleep with open eyes. Then what else do Pisces do? They have gills. So I'm sorry, I'm going to wipe just a part of the whiteboard. Okay, let me just move it up a bit. So they sleep with open eyes, they have gills, they have fins, and what else? Okay, let's just leave that. So the next, so these are called attributes. All right. So for Pisces methods or functions, we have swim, they swim, all right. Then we have they sleep, obviously, and they eat, all right. So these are some of the functions anything in the Pisces class is expected to perform. So because of this right now, all right, we can have tilapia. Tilapia belongs to the class Pisces. So whenever we mention tilapia, we expect something that has gills, something that has fins, something that sleeps with eyes open, swims, sleeps, and eats. When we mention croaker, it's a bit different from tilapia, but hey, same method. So that's basically what this does. So this thing is called this Pisces is called the class, all right? And then tilapia and croaker are objects that belong to this Pisces class. So being objects in the Pisces class, they obviously have the same kind of methods, which is this, and the same attributes. And that's exactly the same thing that we do here. So we have procurement manager objects, all right? I would rather not call this object anymore. Let me call this class. I will call this a class, and I will call this a class. So that the day we decide to hire someone and his name is Matthew, all right, we are going to say Matthew is an instance of the procurement manager class. And when you do this in Python, you just write the code like this. Python knows what you're talking about. That, hey, okay, you're telling me Matthew is a procurement manager. And then automatically, Python expects that Matthew can buy noodles, Matthew can ensure noodles get to the kitchen and all of that. So this way, when you're now writing your code, you can now say Matthew dot buy noodles, which is one of the methods that is expected, all right? And then Python would give you the response that is expected when you perform that buy noodles function, all right? And when you say Matthew dot move noodles to the kitchen, all right? So move noodles. Python knows what you're talking about. So Python performs this same task, all right, which is expected. So most times when you are working in maybe pandas or maybe anything in Python and you see us do this, the name of the object dot either the method or an attribute. This is basically what we're doing. We're doing object-oriented programming. So we're just trying to call the functions or call an attribute, all right, so that we can use that attribute to do something. Yeah. Questions? Anyone? Questions, anyone? Please go ahead.
Maybe when we start practical, because now it's still looking like Japanese and Chinese mixed together.
Okay, so now this is it. So okay, let me use a slide. There is this slide I normally use when I teach object-oriented programming. So let me see if that slide will help. I'm just going to check. Where's my file? Let me see. Okay, so okay, programming paradigms. Yeah, okay, so I found it. Programming paradigms and see if it opens up. Okay, I think, yeah, it's coming up. That should be it. Okay, cool, yeah. So, all right, so I'm just going to share that right away and let's play with it. Okay, so let me share this and let's go. Okay, so basically, let me just put this in view. All right. Okay. So this is just like an intro. And like I told you earlier, the only reason why we even talk about object-oriented programming is because of complexity. Normally, when we had to prepare noodles for just one person, it's just a simple set of procedures. Go to mom and pop shop, buy noodles, all right? Boil water, put noodles on fire, allow noodles to simmer, and then serve noodles. Just a simple set of procedures. But the moment you have to cater for a wedding and you're looking at 5,000 guests, what you're looking at is like, yeah, it's the same endpoint preparation of noodles, but the level of complexity is different. So instead of just preparing noodles for just one person through a simple set of procedures, you now have to involve like actors, all right? So because at that level of complexity, just a simple set of procedures is not going to cut it. Instead, you have to co-opt objects, you have to co-opt people, all right, actors to help you perform at that level of complexity. So in this example that we used, we had a procurement manager whose role was to buy the noodles. We had a kitchen manager who cuts the stuff. Then we had a procurement manager who made sure that all the other parts of the project, we had the project manager, and everything is just amazing, all right? So each of the jobs are called classes. And like I told you, a class is just like a blueprint. A class is just, it's just like a species, like, yeah, that's basically what it is. So when we call a procurement manager species or procurement manager's class, what we're trying to say is, okay, so this guy is a procurement manager. Basically, this is what we expect of them, you know? Like I say, before you hire somebody to fill roles, you have to do like a job analysis. So a job analysis reveals two things: the specification, which is the attributes of the person, and the job description, which are the functions that you expect the person to perform, all right? So these two are what's underpins object-oriented programming: attributes and functions, also called methods, all right? So the functions are like the job description, what you expect this object to do, all right? And the attributes are like the specifications, what you expect them to have. So for example, if you want to look at how it is, all right, how it's going to look like broken down in object-oriented programming, this is what it looks like. So you have a procurement manager who has a name, years of experience, and then what they do: buy ingredients, receive ingredients into stock, ensure safe storage. You have a kitchen manager who has a name, years of experience, and then this is what they do. So this is what happens now when you get to a particular phase in the project. So let's assume now that, okay, so John is the host, is the one making the food. Now, John is also the project manager. He needs noodles. Noodles is the first thing we need to start this project. So at that point in time, what does John do? Who should John call? John is going to call the procurement manager. And that's what happens. And what does he call? He calls the buy ingredients method of the procurement manager. That's basically what he does. So I want ingredients to come right now. So what do? Procurement manager dot buy ingredients. Very simple. And the procurement manager buys the ingredients. So next thing he wants, I want this goods received into the store. What do? Procurement manager dot receive goods. That's what he does. He calls the method. I want these goods to be stored safely. What does he do again? Very simple. Procurement manager dot store goods. He just calls the method. So instead of just going through procedures right now, all you need to do is just create a class, instantiate the object, and then assign all the tasks you need to perform to the particular objects, so that these objects can serve as, like, in quote, project managers, all right, to help ensure that your code becomes modular and becomes robust, so that instead of you having to write procedure, all you need to do is, because you have already programmed all of this into objects, just call the object and call the object method that you want, and it to just supply everything that you need. So let me give you an example in code. That's basically what it is. So these are class properties and methods. Let me see. I think I have something. Sorry, I'm scrolling very fast. Okay. So I think I have an example here, but I'm going to send you this later. You can look at it. The various paradigms: functional programming, procedural programming, and object-oriented programming. So that's basically it. Let me take a quick example right now, and let's conceptualize what this is. So I'm going to come to this place, and I'm going to create the first object, which is the project manager. All right. So let me just put this. Remember, an object can be anything. It can be. It can even refer to a person. It can refer to anything in Python. All right. So, for example, if you want to create an attendance management system, maybe you're building an application and you want to create an attendance management system, you will need to create, one of the classes you need to create is an employee class. All right. So what about employees do you want to capture? Their attributes and their functions that you need them to perform in that app that you're building. So some of the attributes that you're going to capture when you're coding up this employee class. So let me just use this example here. Employee class is you're going to capture the employee's name, and then you're going to capture the employees, maybe do you really need date of employment? I don't know, but let's just put that here. Okay, so we're going to have the employee's date of employment, and you're going to have so let me use a doc string here. So employees.
Your screen is not visible.
Oh, sorry. I thought I was sharing my screen. I'm so sorry. I'm so sorry. I'm so sorry. Thank you so much. Thank you. I'm sorry. So what I'm doing is I'm just trying to create an employee class. And these are the attributes of the employee class. The attributes are the employee has a name, has a date of employment, and okay, let me use an employee ID. All right, so those are the 3 attributes. And then let's have the methods or the functions. So for this particular app that we are trying to create, remember it's an attendance management app. What should an employee do? So there would be like a clock in. Let me just create that as one of the methods. So let me just call this clock in method. And there will also be another method called the clock out method. So that's basically what you'll need the employee to do with the attendance management app. So with this, if I want to create this employee class in Python, you start with the word class, all right? And then you usually use a capital letter to denote the name of the class. So in this case, I'm going to start Python. I'm creating an employee class. Now, usually you would have doc strings to say, okay, this is what this employee class does. So you could just say, this captures employee details. Okay. And functions basically required of the app. All right, so that's just what this does. So then there are 2 things we will define. We'll have to define the attributes. Sorry, so we'll have to define the attributes, and we will have to define the methods or functions. Now, methods and functions are the same, but why we prefer to call them methods is that any function that belongs to a particular class is called a method, right? So that's just why. So most times you hear me use those interchangeably, but actually when a function belongs to a particular class, normal programming lingo ceases to call it they cease to call it a function. They now call it a method, right? So in this case, what I'm going to do is I want to define the attributes. There are a couple of attributes that we should have, all right, in Python for this employee class. We identify them here. Every employee should have a name, should have a date of employment, and they should have an employee ID. So this is how you define attributes in Python, the standard way. Now, hopefully next week, we're going to look at some other non-standard ways that you might see when you open up Pandas or open up any of all of these other applications, or sometimes even in machine learning. You know, there's some non-standard ways classes are defined and all of that. But for this session, we're going to look at the standard. All right, so this is the standard. The standard says when you're defining attributes, obviously it has to begin with a def statement. Then you create something called the init. This init is actually you telling Python, I am initializing a class, all right? I'm trying to initialize a class. So what this does is basically tell Python, hey, any line of code that this guy puts in here forms what becomes the attributes of this object, this class. So I'm going to start with the first thing we put in every class, self. I'm going to explain this self right now, but let me just finish putting in the details. So self, the first attributes that this has is names. So because name is a keyword, I'm just going to use employee names. Let me just put employee name here. So I'm going to put that here like this, employee name. That's the first. Then date of employment. So let me, instead of putting it, okay, let me put it in full. Date of employment. And the third is employee ID. So employee ID. So I've just told Python, whenever you see an employee, whoever is called an employee that tries to use this application and logs in, these are some of the things that you would need as attributes, all right? So now, I've told Python, okay, so you should look for employee name, date of employment, and employee ID. What now? These are like variables, all right? They're not just attributes, they're like variables. But I told you I'm going to explain this self. So this is it. Remember that employee is a class. So we might have 10 employees. We might have one Jake, another one Mary, another one Maria, another one Jamie, another one Rob, another one. So what we are saying is this: Python, whenever we call a person an employee, let's say we are trying to initialize and create Rob as an employee, create it in such a way that the first thing Python should do is go and grab Rob and hold him tight, all right? So that subsequently, it will now be Rob.name, or sorry, .employee name, and Rob.dates of employment, and Rob.employee ID. That's what this self does. It says, Python, bind yourself to whatever instance of this class that is being created at that material time. So let me just finish up this code. Now, I'm going to tell Python that here you should use this emp name as the value for the employee's name, and you should use this, dates of employment, okay, as the value here, and you should use employee ID as, yeah. So this is what happens. Now, let me run this class. So let me run it. So you can see Python recognizes that this is a class. Now, let me call a new employee. So I'm going to say Donald, all right, equals to employee. So I'm just telling Python, when I do this, I'm just telling Python, hey, this guy named Donald is an employee, all right? But if I try to run this, Python is going to tell me, hey, if this guy is an employee, you're supposed to tell me his name, you're supposed to tell me his date of employment, and you're supposed to tell me his employee ID. So let me put all of those right now. Now, I'm going to say Donald, the first thing is his name. So let me put Donald, of course, Donald Matthews. Then his date of employment would be, let me just use 1999. And his employee ID, obviously, is going to be a string, will be 200,987. So now when I run this, Python is not going to give me an error anymore. So now I can decide to say, okay, so if I say Donald dot name, employee name, which is this, Donald.employee name, sorry, EMP underscore name, all right? And I run this, Python tells me his name, all right? Same for when I put his date of employment and all of that. So let's define some methods for Donald. So let's call this clock in. Clock in, all right? Now, again, when you're defining methods for objects, you have to use the word self inside, but telling Python, hey, Python, bind yourself to this instance and then execute. So in this case, I'm just going to put the self here, and then all I'm going to tell Python is just print my name is, okay, let me just use self.name. All right. Plus, I came to work by, let me just use 9 a.m. because I don't want to, I've not imported the library that handles datetime and all that. So I can't use datetime.now. So in order to not mess it up, I will just use something simplistic. So I'm going to run this now. And now, so when I say, Donald, I need you to clock in this morning. Okay, so I'm going to put, okay, so when I say Donald clock in, and I run this, employee object has no attributes clock in. Sorry. Donald. Okay. Sorry. I didn't run the first code, so let me run it now. Okay, cool. So here, this is what it says. My name is Donald Matthews. I came to work by 9 a.m. So that's basically how classes work. All right. There is the attributes, there is the methods, and yeah. So just like when we were trying to assign roles here in this whiteboard, if we call a procurement manager class, we could assign the buy noodles method to it, and then the ensure noodles gets the kitchen method, all right, and like that. So when we call, like we did here, it gives us whatever line of code we have programmed inside this method. So that way we will achieve the same results we're trying to achieve, but our code will now become more modular and will be ready to scale. And scale is very key. That's why it's very, very important. And that's why really we do projects. We have project managers in our offices, not because we cannot just have procedures scattered and running everywhere, no, but because the moment we adopt a project mindset, which is what OOP does, it enables us cluster tasks and functions around objects so that we don't have procedures flying around everywhere, right? So that's the way it works. Now, I believe we're going to look at this in more details next week, but right now I just want to take your feedback. I just want to take questions and, well, queries. Thank you.
I'm still lost. I think maybe I will either have to watch the whole class again, or no, it was really quite engaging.
Okay. Okay. Okay, let me see. Implementation of OOPs and projects. Oh yeah, sure. We could look at that next week. Yeah, time should allow us to look at that next week. So we're fine. Okay, so
good afternoon.
hi, Kazim. How are you?
I'm fine. Thank you very much for your classes. I mean, they are very insightful.
All right.
Sorry, I couldn't join early today because I had an orientation, a virtual orientation, so attend online.
Okay.
So, but I've been going through the courses, like from, I think I've done 4 already. I think,
right.
I'm not sure, that's on YouTube.
All right.
And it's coming out quite well. But I have a question. I don't know, it's not on today's topic because I didn't come early, but I'll try and also look this up before the next class. So one thing I noticed is anytime you are watching, like, is like when you touch any of those functions, it brings out a drop down like Excel.
Okay.
As if you are clicking it like to show a formula. But I think I tried doing that on my Jupyter notebook.
Okay.
It's not coming. So I wanted to ask, is it that you import a library?
No.
For it to do that?
No. Okay, so this is it. Press Shift and Tab, and your Jupyter notebook is going to bring it out for you.
Okay,
Shift,
so
tab.
I'll have it completed. Okay,
yes.
I'll try
Shift,
now.
Do Shift Tab, then it will bring out the drop down. But if you just want to see the drop down alone, just press Tab when you're typing. If you're using Colab, yeah, if you're using Colab, you press Control and space. It does the autocomplete for you, just brings it out for you.
Okay. Thank you very much. I mean, you actually know how to teach, because one of the things I think I had problems with when I started using Python is the fact that you see a lot of examples, but still they don't touch that why. I don't know, because I like understanding the basics. Okay. So when I saw from your first video, I got the intro, like, wow. So I started following. So most of the questions I asked, I had, then I think you've been able to solve like some of them. So I've been following since that time.
Amazing. Thank you.
Yeah, thank you very much.
Thank you for the feedback. All right.
Yeah, you're welcome.
Okay, thank you. So Sahil, yeah, great. So what are the few projects we can use to get a job as a data scientist? Now, I get this a lot. Personally, I think usually before we start talking about projects, because data science doesn't exist in a vacuum. Data science is actually part of a cycle. So there's something called the end-to-end cycle of data science. What happens is it begins with a business need. There is something management wants answers to, and that's how data science starts. Data science doesn't just begin because we, like the task or stuff. It begins because there are usually questions. So management might want to know, what mix of products should we move to the market to get us the best profits that we can have? So in this case, management is trying to maximize profit based on the mix. That is where the data scientist's work begins. So the data scientist will now have to do an end-to-end project that begins with understanding the market, understanding the hypothesis that can bring answers to that question management is asking, and then following through the process of hypothesis testing, EDA and all of that, till you get to the answer. So usually what I tell people is this: pick a question management asks most times. Now, how do I know the question? Being a consultant, I relate a lot with managers. So especially in this part of the world where I am, I get to talk with these managers and try to find out what is the pain points that they have. So one manager might tell you, I'm trying to find out how best to mix the number of staff that I have, based on their skill set and whatever, so I can get the best results. So already that's what he's trying to get. He's now asking me to use data science methods to be able to answer these questions that he has. So if I want to do a project that's going to be interesting to him, I will do a project that will answer that question that he has. And that's one of the things that I try to do. So I try to get questions. So if a manager is asking, how do we optimize based on this so product mix? I say, okay, let's do an end-to-end cycle. So begin with what are the kind of data we need to gather, because that's what data scientists need to work, data. So you try to now ask yourself, what are the kind of data we will need, all right, to answer this business question? And then you now begin to work, you now begin to gather the data. But in the process of gathering the data, you might discover that that data does not already exist. So it means that you would need to create like a form of a database, all right, to warehouse that data. And that creation of a database is usually data engineering. And that's why data scientists dabble into data engineering a lot. You need to know SQL, you need to know all of those. Sometimes it's even worse. The kind of data you're trying to gather are not static data that can be gathered in batch. So it means that it comes in streams. Now, what that means is that you have to learn how to trap streaming data. Streaming data are data that is just flowing in streams, like, from the web, from a phone, from different sources, just streaming in. So you first need to have to calm the streaming down, probably in a data lake or something. And then from there, you move it to a proper data warehouse, which is a SQL database. From there, you now move it into another data mart, which is probably more segmented database, from where you now do your ETL, which is your extract, transform, and load. And then you now do all your beautiful EDA, machine learning algorithms and all of that, or whatever module you want to use, models. And then from there, you now present your results. And in order to do those machine learning models, you now have to ask yourself, okay, how do I serve this to the client to even test it? And then to now deploy it on a continuing basis so that he can use it to solve his problem. So you now start talking about things like APIs. So you talk about how to create APIs in Flask, Django REST framework. You talk about Fast API. Then from there, you talk about how to host it in the cloud. You talk about Amazon E2 instances. You talk about Google Cloud. You talk about Azure. So it becomes crazy. It becomes like very, very wide. So most times you will discover that by just picking a business question, sometimes you need like 1 whole month to set up the framework that will now continually answer that business question for that manager anytime it's asked. When you do that and you can forward that to anybody, any business manager at all, you will get their attention. And I'm telling you what I do. This is how I've gotten most of the clients that I work with. I got to ask questions. Sometimes it's even the person just talks it in person, all right? And then I just pick it and I just grab it and I say, okay, you know what? Let's build the solution. So what data do we need to answer this question? I start hunting for data. Sometimes I even ask them to get me the data. If the data is not available on the inside of the organization, I have to look outside somewhere to get comparative data that I can use, and I just build the whole end-to-end cycle. And then I show them. So this is what I have arrived at. And when you do that, really, you're going to get anybody impressed. Remember, you don't need the whole world to be impressed. You just need to impress one person, the right person. So because I see some people try to do a lot of data science projects and at the end they do a lot of haphazard jobs. I really prefer not spray, like they call it spray and pray, just scatter your efforts everywhere. No, it's really going to task you, because if you really want to build an end-to-end project, it's going to task you. So you really cannot be scattering your resources and your time and your money everywhere. What you need to do is identify the kind of company you want to work for. So I want to work for a Google, I want to work for a Facebook or for somebody. Great. What kind of business questions do their management ask? Give me 2 of them. So I identify the most pertinent business questions that they ask. Then my data science end-to-end cycle begins. By the time I'm done creating a project on that end-to-end cycle, I can just book a meeting and say, so I think there's something I want to show you, so I just show them, and then this is what, so that's how it works for me. But like I always say, there are many routes to the market. So it might not work for you that way, but I'm just telling you that maybe you could give it a try if you've not tried it before. And I'm not saying there's a guarantee it must work. No, there's no guarantee. I can't give that as a guarantee, but I just think that if you do it that way, you will get results. I just think so, based on my experience. So I think I got the question right, Sahil. But if there's still something you think I did not get right, you can let me know. But there's actually, okay, maybe what will happen is I hope we are accelerated. Yeah, thank you, Kazim. I hope we have an accelerated learning with our object-oriented programming. What that will do for us is that we will now be able to, because I'm actually running a data science end-to-end project with a couple of my friends. So maybe by the time we're done with this, I would show you one of the end-to-end projects that we are currently running on, real-life projects, all right? So I guess it's to answer a lot of questions, but it's usually a very, very, very massive, lineup of things you're trying to do at once. Yeah. Sahil, did I get that correct? Yeah. Oh, great. Thank you. Okay, so would there be any other question before we wrap it up till next week?
Oh, good afternoon.
Hi.
Okay, thank you for the class.
Yeah.
I didn't understand some of the things because I've not followed through the classes on YouTube.
Okay.
I believe I will get it.
Sure, you will get it.
So, okay, so the question someone just asked now and the way you explain. So what is the difference between, because there's a lot of buzzwords in the data science, business intelligence. So what's the
difference between,
what's the line between the two?
Okay,
business intelligence and
now,
data science, the one you just explained, this particular project, because we're talking more about the business and how.
Okay, cool. I'm going to explain with a diagram. I like to use that diagram a lot when I explain things. So let me use that. It's in PowerPoint. I'm just going to show it. It's in one of the classes that I teach. So this is how it begins, so that you can see how everything fits into each other. So I think I will maximize this for viewing. And so this is where everything begins. Let me maximize this. All right. Everything begins with a business question. Which is where the whole thing starts. And then based on the business question, once you want to start answering it, you have to gather raw data, all right? So the data might be in batch form, it might be in streaming form, it might be in whatever kind of form that you want. Like I said, a business question can be, how best do we mix 2 of our products to maximize profits? Or what mix of, what kind of, what's the maximum level of costs that we can have, to if you want to minimize loss or something, any question at all. Management asks a lot of questions. Over the last 12 years of my consulting, I've heard like various kinds of questions, ranging from funny to accurately worded and very serious. Okay. So, but the moment you decide that you want to answer these business questions, you need a lot of data. When you get those data, you will have to do some form of data engineering to it. If the data is organized, like a relational database, you put it in SQL. If it's batch, or if it's streaming data, you need a streaming tool, all right, like Kafka. You need like Airflow or any of all of those. Then this would land inside a data lake. From the data lake, you now move to this place that now becomes your data warehouse. But all of these fall into the domain called data engineering, all right? Naturally, a data scientist would not need to do this, but what we've discovered is that it's never straightforward. There are many times we have to, we have to do what the data engineer does, probably because of budget constraints on the side of the organization. All right. So from here, we have when we now finish all of this, we will now get to the part called analytics. And analytics has just two kinds of analytics. Now, it's an ETL process. That's what happens in analytics. Analytics is extract, transform, and load. Load to where? Remember that you are trying to answer a business question. So obviously what you're trying to do is you're trying to create some form of intelligence to your management, all right? So when you perform ETL, extract, transform, and load, and you serve it in form of visualizations, bar charts, pie charts, and all of that to the management, what you're doing is called business intelligence. So you've created business intelligence. That's what you're doing right now, all right? But if you decide that, hey, I want to make a machine intelligent so that I don't have to keep repeating these bar charts every time, so why not me train a machine instead so that the machine becomes intelligent and then the machine can, infer, make inferences, make suggestions, and all of that on its own automatically. That is what you call artificial intelligence. So after your ETL, if the endpoint of your analytics is for management through bar charts, tables, infographics, etc., what you're doing is called business intelligence. Else, what you're doing, if you're making computers intelligent, it's called artificial intelligence. So that's the difference. That's where everything we're doing, this is where they fall in. So this is where the data scientist's work begins, and then it ends here at the point where the business question is answered. So there are some people who help in this value chain, like there is the data engineer, obviously, but the data scientist should be able to do his work. There is the analyst, obviously, the data scientist should be able to do his work. There is the machine learning engineer, but the data scientist should be able to do his work. There is the BI analyst, which is just the guy that creates all those charts and all of those. Again, the data scientist should be able to do his work. That way, the data scientist is always in charge of the results that come up at the end-to-end process. All right. So, Kenny, is this a bit?